Hello and welcome to Medical Dialogues. I'm Anshika Mishra. Hairspray I bring to you from the world of medicine. New study links late-night eating to higher colorectal cancer risk. In a recent study, researchers from Rush University Medical College in Chicago found compelling evidence suggesting that eating late at night, particularly within 3 hours of bedtime, may significantly increase the risk of developing colorectal cancer. The study reinforced long-standing advice from experts to avoid late-night meals, especially those high in fats and sugars. Research has found that eating close to bedtime may disrupt the body's internal clock or the circadian rhythm. Unlike the central circadian rhythm, regulated by the brain's release of melatonin to induce sleep, late-night eating appears to affect the peripheral circadian rhythm. This peripheral system governs how various parts of the body adjust their functions in response to transition from day to night. Disruption of this rhythm could potentially contribute to the increased risk of adenoma formation and subsequently colorectal cancer. An adenoma is a small, non-cancerous lesion that can potentially turn cancerous over time, with an estimated 5% to 10% undergoing malignant transformation. The risk associated with adenomas varies depending on their size and location within the gastrointestinal tract.
Are you also aspiring to excel in medical journalism and delve into the intricacies of health and medical reporting? Explore our comprehensive course on medical and health journalism available at the Medical Dialogues Academy. Learn from industry experts who possesses in-depth knowledge and experience in this field. For further details, scan the QR code provided or access the link in the description box below.
Could rejuvenating mitochondria help fight Alzheimer's? Study sheds light. Although scientists still do not know the exact cause of Alzheimer's disease, most agree that the disease is characterized by the clumping of certain proteins, beta amyloid and tau, in the brain. In a study published in the journal Neuroscience, scientists examined how the accumulation of large protein clumps in the brain, called insoluble proteins in general, might accelerate Alzheimer's disease. Protein clumping happens when proteins in the brain stick together in the wrong way. In Alzheimer's disease, two types of protein, beta amyloid and tau, are involved. Beta amyloid forms sticky plaques outside brain cells, blocking their communication and causing inflammation. Tau proteins, which normally help support brain cells, form tangles inside the cell, disrupting their function. These plaques and tangles damage the brain, leading to memory loss and confusion seen in Alzheimer's disease. In the study, researchers using a worm model discovered that beta amyloid causes a massive amount of insolubility in other proteins, especially in a subset of proteins researchers call the core insoluble proteome. Study finds the ability of cancer drugs to lower blood sugar levels. In a study published in the journal Proceedings of National Academy of Sciences, University of Oklahoma researchers investigated a drug's ability to prevent fat buildup in the liver. This condition often accompanies obesity and can lead to serious fatty liver disease. The study expands on an earlier finding by Tiagang Lee, PhD, and a team of researchers at OU Health Harold Ham Diabetes Center. They discovered that a drug originally designed to fight cancerous tumors can also enhance insulin sensitivity and reduce blood sugar levels. This drug works by stopping the breakdown of a particular protein essential for all cells to react to insulin. Cancer remains a significant global health challenge, with its prevalence steadily increasing over the years. According to the World Health Organization, cancer is one of the leading causes of morbidity and mortality worldwide, responsible for an estimated 10 million deaths annually. In the study, researchers studied mice and removed a gene called the COL3 from their livers. Normally, this gene is inhibited by the drug to stop the breakdown of a specific protein. By getting rid of the gene, they could see what happens when mice become obese from eating a lot of fatty foods. Thank you for watching. Stay tuned to Medical Dialogues for more updates.
Never miss a medical update from Medical Dialogues. Like, subscribe, and press the bell icon.